Hello everyone, my name is Anvita Bansal and we are back with our another lecture from SDE Sheet. So let's have a look what is our problem for today. Let me show you guys. Okay, let me check if you guys are able to see the screen. Fine. So let's move ahead. Today's problem is allocate minimum number of pages from searching and sorting, the last problem for this section of your SD sheet. So let's have a look at this problem. So first of all, this is a very nice problem. Second thing, it has been quite frequently asked in lots of interviews, even in Google interviews. So let's understand this problem. It is given that first thing is that you understand the problem itself, okay? You have n books, right? These are the number of books that you have, and each book has certain number of pages which is given in the array itself, right? So the elements in your array represent the number of pages in the book, right? I am explaining you in the layman, in normal words, rather than going with this definition, okay? Then you have m number of students. These are the two students that you have. What you want to do is, the goal is to find the permutation where the student with the most books allocated to him gets the minimum number of pages. Now what do you understand by this? So out of all the permutations, you have to allocate the books to these students. You have two students. So you want to allocate books in such a way that any student which gets the maximum book, that is the minimum among all the permutations. I will explain you what does that mean, okay? So the most books allocated to him gets the minimum number of pages. Now let's understand what else. Return -1 if such a division or allocation is not possible, and it should be in contiguous order. For example, there is student 1. I'll tell you everything, every example. For now, just have a look at what they are saying. So for example, you have two students. Let's understand this case. Let's have a look at this. I hope you have already come on live. Okay. Just a second. Okay. So let's have our test case right here. Give me a moment by the time. So this is what has been given to you. Let me... So this is what is given to you. What does this mean here? Let's understand it. Okay. So what they're saying is, you have to understand this with complete focus here. You have books with these number of pages, 34, 67 and 90. And you have two students, right? So what can be the possible division, allocation of books to these students such that the student getting the book, the maximum number of pages is the minimum? I'll tell you what. Have a look at this statement here. What they're saying is, the student with the most books allocated to him gets the minimum number of pages. Okay, that is the maximum number of pages is the minimum of the all permutations that you have seen. Let me tell you, this means that with a smaller example, let's understand. We have 10, we have 20, we have 30. Okay, and I am saying you have two students who you want to distribute the books. So what can be the possible permutations in which you can distribute the books? First of all, understand certain constraints. So you have some just a second, let me just... There are certain constraints. The constraints are that, first of all, allocation should be continuous. It should be continuous. When I say continuous, it means if student 1 has got book number this book number 1, then student 2 should be allocated with 20 and not directly 30. We cannot allocate in this way that one student is getting 20, other student is getting, let's say there were you will understand why this contiguous is meant here. Let's say you want to distribute two books to student 1. So you cannot distribute him 10 and 30. That is the wrong way. You can only go in continuous method. If you want to distribute, you can distribute the first two books, not the first and the last book, if you want to distribute two books at all. Okay, this is the meaning of continuous. Second constraint is that every student should be allocated. No student should be left. Every student should get the book. Now these are the main constraints. Now let's see if my student 1 gets book number 1. What can be the permutation? This is 10, this is 20, and this is 30. One is that I put a partition here. Okay, student 1 gets this book and the other two books are taken by student 2. Another possible way is that I put a partition, because this is a smaller test case, that is why I have taken, so that you can understand. So other possible way can be, okay, you put a partition here at 20, after 20. So basically student 1 will get these books and student 2 will get these books. Now you tell me, in both the, are there any more permutations possible? Can you divide 10 to one student, student 1, 20 to student 2, and no 30 pages books is allocated? This cannot be the case. You have to allocate all the books. All books should be allocated and all students should be given the books. Now whatever permutations you have to check. Tell me one thing. First, answer 1 was this: when you distributed 10 and 30 plus 20, that is 50. Other permutation was you distributed 10 plus 20, 30 to one student, and other student got 30 books. Okay, so basically these are the pages. Okay, these are pages that you are allocating. Student 1 is getting 10 pages, student 2 is getting 50 pages in solution 1. In solution 2, you are distributing it like this, that one student is getting 30 pages total and other student is getting 30 pages. Now your problem demands you to check, to find the permutation where the student with the most books allocated to him gets the minimum number of pages. What does this mean? First, tell me most number of books is with which student in both the cases. That means which student has the maximum number of books is proportional to maximum number of pages. So in both the solution, which student has maximum number of pages? Student 2 here has maximum number of pages. Here the maximum is same, that is 30. So the maximum number of pages here is 30. Now out of both the solution, in which case the maximum is smaller? So the maximum is smaller in case number 2, that is in second case, where you are allocating books as 30 pages and 30 pages. Now you got the answer. So answer for this case should be the allocation of 30 and 30. That means you are distributing book 1 and book 2, both books to student 1 and the last book to student 2, and not in this way that you are allocating book number 1 to one student, book 2 and 3 to other student with 50 pages. So that is the meaning of the statement of your problem, where the problem statement says that maximum number of pages that are allocated to any student should be minimum. This is what is meant by this. I hope the problem statement is clear to you. Fine. Now as the problem says, it is very simple to understand this thing, that it is asking you for permutations. So since the question itself is saying that what are the maximum number of, let me just erase it. Okay. Since the problem itself is telling you what are the maximum permutations, so what is the permutation possible? So first thing is that you can find all the possible permutations. You are given an array of books, let's say 10, 20, 30, 40. You check all the permutations and students, that is M given to you is 3. So what can be the possible cases? You put a partition here, you put a partition here, this is giving to student 1, you are giving this to student 2, and this is taken by student 3. Then other possible case can be you put a partition for student 1 at this place, then student 2 gets this and student 3 gets this. Other possible permutation can be that student 1 gets what? What can be the other permutation? Is there any other permutation possible? 10, 20 by student 1, 10. In other cases, you will not be able to allocate the books to all the 3 students. So this is the possible case, right? Now, are you going to find permutations? No, because this is going to take a lot of time. We can optimize this solution. How to optimize it? Let's discuss it now. In this, it requires lots of logical thinking. What logical thinking is needed here? Let me tell you. I am taking this test case for the ease of understanding and the ease of calculations, nothing else. Okay. And the number of students is M is also 2 here. Okay. Now tell me one thing. If I were to allot the book to any student, right? If I want to start allocating, now you don't think of permutation in the permutative way. Now just think it. Now you want to allocate book. You start with student 1, you give student 1 10 books. Now you are left with 1 student. So you will, let me just increase this test case for better understanding, because we have already discussed. See, the entire problem here, lies around the explanation part. If you understood this problem, then code is a little lengthy but very easy. Entire thrust is on the explanation. Okay, so let's understand it. I am telling you that your students are 3 and you have to allocate 4 books to these 3 students. How can you allocate them? Tell me one thing. I start with student 1. Let me allocate it in this way. This is your student 1, this is for student 2, and this is for student 3. Okay, let me write it. Student 1, this is student 2, and this is student 3. Tell me one thing. If I start allocating, what is the best possible number I should start with so that my operations I am doing to check the permutation are minimum? What is the intuition behind this? If let's say I give student 1 10, now I am left with these many books, and give other student 20, I am left with 70, I allot 70. Okay, let me do one thing. Let me increase the count of student 1 that I am giving. Let me start with allotting 20 to any student. No matter which student I am choosing, just think it that I am now starting with any student, allotting it 20. Let's allot 20. Now I am left with 10, 30, 40. Okay, obviously I know I will be continuously allocating. So whenever I am choosing just one book, I am choosing it any. Either I can choose 10, either I can choose 20, 30 or 40. Tell me one thing. Which book would you prefer to choose first for any student? If I allocate any student 10, then what will happen? I am still left with these many books to allocate. Then what is the maximum that any student can get? I choose 20 for other one and rest is 70. Just think of giving just one book to the 2 students and remaining books to the 3rd student. Now I choose to give 20 to any one student. Then I am left with other student to give 10 book, right? And again this will be 70, so this wouldn't be a good case. So what can I choose? Let's choose 40. I choose to give 40 to any one student, and then I can choose to give 30 to other student, and I can choose to give 30 to other student. This can be one good case. Other case can be I choose to give 40 to one student, then I can choose to give 50 to other student and 10 to other student. You getting my point? What I am trying to explain here is I am choosing one student and allocating the book. So I am asking you, what would be the best start to start allocating the books? You see here one thing. If I start allocation with the minimum book that I have, then there is a high chance that I might need many more operations or many more searches to get to that permutation in which the student with the maximum number of pages, that maximum is minimized. I hope you're getting this point. What I want to say is, if you start with the smallest value of your book and you give it to one person, okay, student 1, I am giving you 10. Now let's say there are only 2 students, you are giving 10 to one student, and you have only 10 and 20 30 books. Okay, 10 10 30 40. Out of these, any one student, you are starting with 10 and the remaining is left with 70 only. There is no other way. Then you say, let's not start with 10. Why start with 10? Because obviously the thrust will be, obviously the other one will be more weighted one, right? The weight of books on other would be more. And what I want, that number of books is minimized. The maximum number of books is minimized. It should be balanced. You have to understand it in this way. You have stack of books. How can you just visualize a stack of book in a bookstore? 1 stack, 2 stack, 3 stack, where each stack is representing the student. So if you give them one book to one student and you have lots of books, then obviously other stack is going to be bigger, and the third stack might be bigger than the second one, or no, might not be, or maybe equal to the first one. But in order to balance them out, do you understand this thing, that if I increase the start my count with allocating a little more number of books to one student, then others can balance the height of those books. You have to understand that way. So what I want to explain here is, if you start your allocation in such a way that to the first student that you are allocating, you allocate him the book with maximum number of pages. So from the given lot, let me write this here. So what I want to explain is, you have certain books. This is stack 1, this is stack 2, and this is your stack 3. It can be in this way, right? If you choose to give the minimum book, it is, and you have only, let's say, 2 students, then the weight on the other one would be the higher one, and you do not want such a permutation. What if balance them out by giving equal number of books if possible, or if not possible, at least don't allocate the minimum book possible. Whatever lot you have, you can allocate either the maximum book to that person, right? If there are more students, that might help you. So what I'm trying to explain here is, don't start your search by allocating the minimum of the lot, that book, to the student. Start with the maximum pages that you can allocate to one student, right? Fine. So starting off with, start by the book with maximum pages. Okay, now tell me, if you start like this, in the worst case scenario, if I tell you for this test case, let's say I am telling you only have one student 1. So how many books is that student going to get? In that case, all the books will be allotted to this student. You getting this point? So in the worst case scenario, the maximum number of, basically what can be the range of your division allocation? The range can vary from that you start your search of allocation of books in such a way that you allocate you start with allocating the book with the maximum number of pages, and go till, from 40 you go till what is the max total number of books that you can allocate to any one student. In the worst case scenario, if you are left with only one student, that one student can get all the books that you have. So in that case, that will be the sum of all books. So when your maximum can go till so large value, why not start your search by allocating, rather than allocating 10 to any student, start with allocating 40 to any student. I hope this part is clear. This is very important for you to understand. Let me check if you guys are able to see my screen. Okay. If you have any doubt, meanwhile, you can write it in the chat. I'll have a look. Okay, fine. Just a second. Let me just delete this one. And I think that's fine. Okay, fine. So what does this lead to you? This leads to you searching for allocation, searching for the right allocation, for the appropriate or the right allocation of book, searching for right allocation of book. What is the kind of search that it is leading to? We are choosing a low for the allocation, and we are choosing a range for our allocation. The low can be the maximum of your array, maximum value of array, which represents maximum of given array, which represents maximum of array, and high is the sum of all books, sum of array, which represents what? So maximum of array represents book with maximum pages. Okay, and sum of array represents that total pages that can be given to one student, total pages that are present in all. You understand? If let's say you have only one student, you are giving all the books to him, so he is left with all the pages that were possible. Okay, so when I start my search in this way, what I am doing is I am starting with 10, 20, 30, 40. M is 3. You take your low as 40 and high in this case will be what? See, what are the possible ways? You give 10, you give 20, 30 and then you give 40. Is this one way? Yes, this is one way. Other ways, you give 10, 20, you give 30 to other, you give 40 to other. Other case can be, what can be other? Is there any other case possible? Let's check. 10, 20, 30 is not possible. 20, 30 we have given. 30, 40 is possible. Yes. You give 10 to one, 20 to other, and then 30, 40 to other. Right? Any other possible way? Each 40, 40, 30, 20. I think that are the possible solutions for this test case. Now tell me what should be the answer for this test case. The I'll tell you what you have to return as answer. Tell me what is the maximum number of pages any student is getting in this. Here the maximum is 50. So this is the maximum from this solution. That is 50. I am writing the max here. This is the 50. Then maximum from this solution is, this is 40, 30, this is 30. So maximum from this solution is 40. Maximum from this solution is 70. Now you have to return that answer in which the max is minimum. Max is minimum of all the solutions. Min of all solutions. So tell me, out of 50, 40 and 70, these are the maxes of each solution, and out of these maxes, which is the minimum? 40 is the minimum. So I want the answer with 40 to be returned. So I want this kind of allocation, that student 1 gets 10, 20 books, that is total 30 pages. Other student also gets 30 pages. So you seeing how balanced this kind of allocation is. That is what we want, and we want to return this value. That is the maximum book that you are that the student in that allocation is getting. I hope this is clear. Okay, so how are we going to solve? We are going to use binary search for this problem. Binary search, so that a searching part can be done in log n of time. That's what your binary search takes. Now we have to keep certain checks that we will be doing. So what is the high that you can? High will be the maximum number of books that can be allocated to any one student, would be the sum of all these values. So what can be the sum? 70, 100, right? That is what you can allocate. Fine. Now tell me one thing. Let's take some mid value. Mid will be 140 by 2, that is 70. Now my check is, that is 40 plus 100, low plus high by 2. That's what I am taking as your mid value here. Now tell me one thing. I am going to iterate in such a way, I am going to allocate in such a way that I have chosen my bar. My bar is, you are choosing your bar value. Your bar is set. You are saying whatever mid you are getting, you are choosing that as your bar. And here your bar is 70, which means my allocation of books to any particular student, should not exceed my bar. That is 70 in this iteration. So let's start allocating the books. So if you are given 10, 20, 30, 40, 10, 20, 30, 40, and your bar for now I have set it to be 70. So student 1 can get 10, it can, if I take another value of your array, that is 20, it is still 30. 30 is still less than 70. I can give him one more book, 30. Now the number of pages he has is 60. 60 is still less than 70. You have to compare with your bar value, which is 70 here. So till the time you are not exceeding your bar, keep allocating the books to your student. Now you are allocating 40. So this was already 60. If you allocate 40, it will become 100. So that will exceed. So do one thing, as and when you exceed the bar, go to other students. So this is the case for student 1, that this is the number of books your student 1 can get. Now you are left with one more value in your array, 40, that you can allocate to student 2, and that is the allocation that you can do if you choose 70 as your bar. You getting this point? But from this iteration, what do you observe? You are iterating over all the values from 0 till n in your array. You are keep adding the number of pages that any student can get. If the number of pages exceeds the bar, you take one more student, and so on and so forth. You keep taking number of students until you have iterated over all the books in your array. Okay, then in the end you will check how many students you have allocated the books. Here you have allocated the books to 2 students, and how many students were there whom you wanted to allocate? So m that I gave in this test case was 3. So you wanted to allocate to 3 students. You cannot leave any one student, or also you cannot exceed any student in your allocation. So if your allocation has been done in such a way that number of students that you have allocated the books come out to be less than m, that means you can do more search. And your bar can be lower down. If you were setting a bar that any student can get maximum of 70 book, if we were doing allocation in that way, then number of students we were not able to fill up to 3, right? One student got left. So why not reduce the maximum book that we can give to any one student? If I reduce my amount of book that I can give to one student, I can maybe accommodate one more student. So that is my idea. So one thing I got for sure, that my range was what? My range was from, I had chosen 70 in what way? I chose 70 in this way, that my low was the maximum of your array, 40, and your high was 100. 100, right? What was your high? 100. And you chose the mid of these values, which was 70, and you chose mid, that came out to be 70. But with 70, the solution that you got, you saw that students were not completely given, all students were not taken. So one thing is for sure, that 40, any answer that you will get, that should lie within 40 and 70. Your maximum can be reduced. So let's check the new mid value. New mid value can be 40 plus 70 by 2, right? 55. I hope this is clear. So now your new bar is 55. How did I select it? My low, now this time your high became mid minus 1. It became mid minus 1 in terms of calculation. Here I am just showing by telling you that this time you already checked for 70. Now just reduce your mid value by 1 and it will be 69. So basically choose a mid of low was 40. Now your range becomes 40 to 69. Earlier your range was 40 to 100. Now you have reduced your range to 40 to 69. Okay, fine. So let's say now your new bar is 50. That is the mid of these two values. That is why we are using binary search, so that our search number of operations to search becomes less. Okay. Now array was 10, 20, 30, 40. Now you have to allocate the books such that the books do not exceed the value 50. Right? The number of pages do not exceed 50. So let's start allocating. Give 10 to one student. This is for student 1. Give 10, ST1. 10. Can I give 20? Yes, it's still 30. 30 is less than 50. Can I give 30? If I give 30, it will become 60 and 60 will exceed this. So I cannot give 30. Let's go to student 2 and start giving it to him. So give him 30. 30 is less than 50. Can I give him 40? I cannot give him 40 because 40 plus 30 will be 70 and it will exceed 50. So let's take my student 3 and allocate him 40. Can I give any more book to this student? No. I have reached the end of my array and this is what I am at the end. So at the end, the total number of students are 3. And allocation is of this way, that first student is getting 30 books, other student is getting 30 books, other student is getting 40 books. So I will say, this solution will say, if students is equal to m or it is less than m, I want to reduce my bar and check if that can be the possible answer. Earlier, my bar was 70, right? I reduced the bar and I found one answer, one allocation answer, because here I am able to fill all the 3 students. So 50, with this, I will update my answer as 50, but I will still check, can this value be reduced further? Can this value be reduced further? So for that, I will check what I will reduce my bar further. Now my bar will be, your low was 40, your bar high was 50, right? You will make this as your high value, and what is the mid of these values? That will be 45. Fine. Now check for answer with 45. Can, if let's say you take 45, can you still allocate the books? That is what you want to check. So student 1 gets 10, other one gets 20, 30 is still less than 45. If you allocate 30, it is not possible, right? So let's go to student 2. Student 2, student 1, student 2. Student 2 gets 30, it cannot get 40 other. So in this case also, this answer is possible. So I can reduce my answer by 45. Keep that, so that I can know that 45 can also be one such answer. But 45, if I that tells me the maximum number of books that any one student can get in the allocation, which should be minimum. Okay, so it says, okay, 45 can be one answer. Finally, next let's check for other thing. Then 40 and 45, actually ideally it will be 44 and some. Since you see here, I am not exactly using mid minus 1 as my high value. My intent to tell you is, if you are able to satisfy the allocation, that you are able to fill all the students, or the students are not completely allocated, you are reducing your higher range, higher value to, you are making it mid minus 1. Okay, but if let's say you are not able to allocate, or you are allocating in such a way that you are exceeding the number of students, in that case what you will do, you will make your low as mid plus 1, and your range will be from mid 1 plus 1 to high, and then you start allocating. So this binary search itself finally will give you an answer that will tell you the maximum number of pages in such a way that is the minimum allocation that can happen for any student. Any doubt so far? Fine. So if I show you the actual test case here, if you see this question here, is there any smaller one? Okay, if I take out this 15, 17 and 20, one more test case, 15, 17, let me just erase it. You have 15. Let's dry run our explanation over this. I think this was 15, 17 and 20, and number of students is 2. Okay, so what is the maximum value that you can take as your low? So your low will be the maximum of this array, which is 20, and your high will be the sum of this array. So that comes out to be 32 and 52, right? Okay, so tell me one thing, the first possible bar that you are going to set will be mid of 20 and 52. So that becomes 72 divided by somewhere 36. So I am saying that in your allocation, no student should get more than 36 books. So let's try to allocate student 1. Let me just do it like this, 20. This is your range, and this is your value bar that you are setting. Okay, and then you are iterating for 36. You check student 1 gets 15, 17. 15, 17 is it exceeding 36? It will become 32. 32 is not exceeding, but if you give him 20, it will exceed. So student 2, let's give 20 to 26 by 2, so somewhere 28, right? if 28 is the bar that you choose, let's start allocating the books to student. Can I give my student 1 15? Yes, I can give him. Can I give him 17? No, because it will become 32, it will exceed. So student 1 gets only 15, okay, pages. Let's give student 2 17 pages. Can I give him 20 also? No, 20 cannot be given because it will exceed 28. Student 3 now can be given 20 books. After this iteration, I see that number of students had exceeded m. It exceeds m. M was 2. So the number of students that in this allocation I need will be 3 if I take 28 as my bar. So one thing is for sure, that I am not going to get any value less than 28 as my allocation, the answer of my question. So I should search for values greater than 28, and this time the range would be like this. The range will become 28 to 36. Now your range becomes, I'm writing it here so that you can see all the. Now the next comparison would be when your range is 28 to 36. That is what you are choosing for next. And till now what was the minimum? So this is 36. With 28 you could not get any answer, so we will simultaneously store answer. You chose 38 as your mid value and you were able to allocate to 2 students. So till now 36 can be considered as answer. Then when you chose 28 as your answer, you exceeded the number of students. So 28 cannot be the answer for sure. So we don't need to replace answer with 28 because this cannot include in the answer. That is why we have increased our bar now. Because with the bar, when we made it lower, we were not able to allocate to 2 students. We needed more students to give those books. So let's increase our bar so that number of students can be reduced. Now when we increase our bar, this is what we get, and let's choose the mid of these values. So it becomes, how much is it? 14. Is it 64? Fine. So what will be the value in this case? It will be somewhere around 32, right? The mid will be somewhere around 32. Okay. Now tell me, if I choose 32 and start seeing the students. Student 1. Let's start with student 1. So student 1 gets 15. Can I give him 17? 17, yes, I can give. It is equal to 32 only, so I can give him. Student 2 can be given 20. Yes, it can be given 20 and nothing more left. So this can be one answer. Is 32 less than 36? So I can replace it with 32 here. So my answer is replaced with 32. Now my binary search will say, if 32 can be one answer, let's lower our bar and check if we can get any value less than 32. So now our range becomes 28 to 32. And let's find the mid of these values. So it will be your 60, right? 60 by 2, 30. So this will be 30 now. Now I will say check if you can allocate maximum 30 book to students, and how many students will you be allocating now. So student 1 can get 15. Can it get 17? No. 17 will exceed 30. So I cannot give 17. 17 is not possible. So allocate 17 to second student. What is the next value? 20. Can I give him 20? If I give him 20, it will become 32. So I cannot give him 20 also. So let's take student 3. So student 3 gets 20. Now, but in this case, you get total 3 students, and you cannot exceed the value of m. So answer is still 32 only. Okay, if you have already exceeded, that means for further smaller values you are not going to get the answer. So your range becomes 30 to 32 now. Again, for 30 to 32, what are you going to get? It's basically 31. So we will check for 31 as our answer. Can 31 satisfy the condition? So student 1 gets 15. It cannot take 17. Student 2 gets 17. It cannot get 20. Student 3 gets 20. So this is also not satisfied. Now if this is also not satisfied, which means you need to lower your bar, right? So 30, now range will be 30 and 31. So 30 and 31's mid will be 30 again. Okay, right? Fine. So if you allocate 30 books, then what can be the division? You give 15, but you cannot give 17. You can give 17, you cannot give 20. Again, it will be 30. Now you have already reached till low. You cannot exceed the lower value or your higher value. So binary search will stop here because your high has become equal to low. Because now if you want to search, even if you want to search, what will you do? You will say that for this case also 30 is not possible because we are already we have exceeded the count of m. So I should reduce my bar or increase my bar. I should increase my bar so that number of students can be reduced. So if I increase my bar, my next possible answer range would be 30 to 31. Here also you will get 30 as your mid. For your understanding, here also I will be allocating 3. So if you increase your range now, it will be from 31 to 31. So your binary search will say stop. Now whatever answer you have, you just return that. And this value will be returned. So this value tells you that whatever allocation you have made in such a way that one student is getting 32 books, which is 15, 17, sum of 15 and 17, and other student is getting 20. So this is the basically allocation that your question demands you to be, and you will return 32, but I am telling you that 32 corresponds to this allocation. What was the other allocation possible? That one student gets 15, other student gets 17 plus 20, that becomes 37 number of books. So this allocation is better or this allocation is better? This is how much? 32. 32 and 20 is better, 37 or 15 is better. So the question clearly told you that maximum should be minimum. The maxes of all the solutions should be the minimum. So 32 is the better case. The maximum of this is 37. Maximum of 20 and 32 is 32, which is the minimum of 37 and 32. 32. So that's what you are returning. I hope the explanation is completely clear to you all. Now let's move to a code and understand. Let me check if you guys have any doubts. Fine. Coming on to our problem statement, and let's start solving it. So in this question, since you have already understood your problem, okay, we will be doing nothing but simply writing the function. And fine, we have to apply binary search, correct? And binary search, for that we will be writing other function which will tell us if it is possible or not. So let's do that. Okay, so let me define int sum as 0, right? For int, I am iterating over my array, I is less than a, I plus plus. I am calculating the sum. What is the sum? Sum plus equal to a of I. Also, I want to know what is the maximum of my ARR. So int max, let it be 0 initially. Let it be 0 initially. And maximum value would be max. With max, I am finding max value in array, so that can become the lower part of my range. I hope that is you are understanding this thing. So max is equals to math dot max of a of I comma max. This will return me max. So once I am out of this loop, I have the low value and my high value of the range. Int low will be your max and int high will be sum. This is what we discussed, right? We discussed that lower range, in the range the lower value can be the maximum of your array and the higher value can be the total sum of your array. That is the total number of pages that any student can get if you have one student in the worst case. Now we will apply our binary search. While low is less than or equal to high, okay, that is how you do. You are checking, what were you checking? You were taking a mid value. Int mid is equals to low plus high minus low divided by 2. Fine. And then you are passing this mid value to function which will tell you if allocation is possible using this method or not, right? That's what you are doing. So in order to check, we will check if, let's say I have written one helper function which is taking your array as it is taking the length of your array, it is taking the m number of students given to you, and it is taking the mid value. So you will check if this array returns you, if this function returns you true. Let me write it is possible. Is possible is the name I am giving to my function. If this function will return you true, that means it will tell you that allocation is possible. Allocation is possible. So you will say if such allocation is possible, let's store our answer. Let me take some answer. Int answer as what can be the answer? Let's take it 0. Let's take our answer as 0 as of now, and we will keep updating it with the bigger value. Because why there is, I am taking it 0, you will understand. There's no other value. The pages cannot become negative, the count cannot become negative. Okay, that is why I've taken it to be 0. Okay, so if this function returns you true, it means it is telling you that such answer is possible. So first of all, update your answer with mid, right? And now you reduce your bar, so make your high as mid minus 1, so that you can check if any further possible value, any further smaller value is possible for your answer, right? In other case, right, this is your, if your this function returns true. In other case, you will increase the bar, because solution was not possible, that means you have exceeded the value of number of students, so increase your bar. So your low value, your low will become mid plus 1, right? That's what you are doing. Okay, just a second. Fine, now let's write our function, and when you come out of this while loop, you would want to return what? You would want to return answer, because that is what answer would have stored, right? Now let's write our public static void, not void, boolean is possible. It is returning with true or false. It is taking your ARR A, it is taking your length of array, it is taking the number of students, it is taking the mid value, which is setting your bar. Okay, so what are you checking? First of all, let's take number of students that you are allocating the books. We are starting with 1 student as our allocation, and let's take the sum that you are giving to any one student. Initially, let's say it is 0. Now for I and d, you are iterating over your array. I is less than length of your array and I plus plus. Okay, so any student can get x is plus equal to a of I, right? You will simultaneously check if x exceeds your value of mid, then what? That means you have to give it to another student now. So you make student plus plus, right? Initially it was student 1, you started with 1 student, you gave him first value of your array, let's say 12. Then you check whatever the mid is. If 12 is exceeding the mid value, which it will not, obviously, in this first case, then what you want to do is you want to increase the count of student. That means now you are allocating it to next student. Fine. So if you are allocating it to next student, your sum, your x should become now a of I, because on adding a of I, x exceeded the value of mid. That means a of I itself cannot be added. That is why you are going to next student, and next student now would be starting its allocation from a of I value. If it is not, if x is less than mid, you don't need to write else case. That is what you are doing. You will simply keep iterating in the else case, and finally when you are out of the loop, you will return what? You will return if your x is less than or equal to m, then you will return true. Otherwise, if x, basically if not x, if students is less than or equal to m, you return true. Otherwise you return false. Why? That will go to this case. In the false, if this is true, then you will check for further cases. If it is false, then your, for cases where your range gets reduced, your high becomes mid minus 1. And if it returns false, that means you have exceeded the number of students. If you have exceeded the number of students, that means increase your bar. For increasing the bar, your low will become mid plus 1. So that is what we are trying to do. I hope this much is clear to you all. Any doubts, you can ask me. Fine, now let's try to, I hope this works. Let's try to directly submit it. We will see if there is any error. Okay, and what? Okay, first thing is this should be n because it is the length, capital N rather, and the other case should be I is less than capital N. Okay, and then here I should pass capital N, capital M, A N M because it is NM. Here I0, X is fine. Students I have taken, so students plus plus. Let's check it now. Okay, so one more thing I have not handled here. If let's say the number of students M is greater than, if number of students are greater than N, that means allocation is not possible. You will be left with students, right? Even if you allocate every student one book that you have, you will be left with some students who those are not allocated. So that case you will return -1. Fine. So this was a very nice problem, I would say. This is such problems make you to go towards more of the thinking part, and rather than just using some specialized function or maybe mugging up certain things. So this, you see, the code was code did not make you take many efforts. Code was somewhat effortless as compared to the logical thinking. The entire thrust from the beginning of this problem, since this is the reason I spent a lot of time in the explanation using around 3 test cases. I kept repeating on any one test case. For this sake, I made dry runs only for this sake, so that you understand this problem. If you are able to explain clearly, that pretty much tells how clear you are with the logic and approach. And if you are good with such basic coding, what did we use? We used binary search here. Binary search takes how much of time? Log n of time complexity. So basically your binary search took log n of time complexity, and for binary search you are putting a condition to check this case, which is approximately taking on of time complexity. So overall it is of n log n time complexity, right? So overall it is of n log n of time complexity. So I hope this problem is clear to you. So overall it will take in binary search big O of n log n of time complexity, and that is all about this problem. So I hope you have understood this. Not even if in one go, repeat the problem, repeat the logical explanation that I have done, and you will be then once the explanation is clear, I would really recommend try to code it yourself and then come up the solution if you are not able to get it right in one go. Okay, so that's all about this problem. Any doubts you can write in the chat, otherwise we can wrap it up. Fine everyone, then that is all for today. See you all. Let me just I hope now you are able to see it. So if you were not able to see the code, this is what I have written here, and you can look it this way. Fine, so let's wrap it up. Thank you everyone. Bye bye.